Okay, so this objective is on power theorems. It's just a nickname for what we are dealing with these formulas. But they are the exact same pictures and figures that we were dealing with in the last objectives when we were finding angles and arcs, except now we're going to be finding the segment lengths and the measures of the lines instead of the measures of the angles and the arcs. So we learned before that if we have a vertex outside the circle, that we have the angle is equal to 1/2 the big arc minus the small arc. Well, fantastic. That's useless to us now because we don't care about the arcs and the angles. Now we want to focus on how long these segments are. So we're going to have a new formula for when the vertex is on the outside. Same thing here. Before we learned these properties, same thing, 1/2 minus the arc, but now we're just going to focus on, okay, great, we want to know what is the measure of these lines, not the angles and the arcs. So let's look at the first example. First thing we notice is that the vertex is on the inside. A quick review for our angles and arcs, we learned that the angle is 1/2, and here we add our two arcs that the lines created. But we're not dealing with angles and arcs, we want to find segment measures. So we're going to call this a chord-chord segment, because this is a chord intersecting with a chord inside the circle. So first, let's fill in the information on our diagram. They tell us that AE is 7. They tell us that EC is 9. ED is 4, and we want to find BE, so I'll just represent that with an X. Using the formula that they are giving right here, we can see that in order to solve, we are going to set up an equation made up of all of the parts. So the parts and the parts that are being multiplied need to be from the same chord. So if I'm going to multiply a part and a part, I want to make sure that I'm multiplying part AE and part EC because they form one chord. I also want to make sure that the other side of the equation is formed by the other chord. So the part DE multiplied with part BE. And they not only show the generic formula here, but they also show the specific example using the letters from this diagram. So let's go ahead and show our work in the space provided. We have AE is one part of my green chord, which is 7. And EC is the second part of my green chord. So I multiply part times part. Then I want to multiply the parts of my pink chord. So I'm going to multiply 4 times X. So 7 times 9 gives me 63. And that's equal to 4X. And in order to find my X, I just simply divide on both sides. And I get 15.75 for my X. They did ask me to find BE, but BE was being represented by X, so finding X is enough. I don't need to worry about substituting back in to find BE. And that's it. So again, the math isn't that difficult. It's just knowing which formula to use for which figure. So again, when the vertex is inside and we have two chords intersecting inside, we want to do the part of one chord multiplied together equal to the part of the other chord multiplied together. And then you solve. Let's go ahead and move on to the second example. So now we see that we have a secant-secant situation where my vertex is on the outside. So this changes our formula a little bit. Now instead of part and part, we have the outside piece of the line times the whole piece. A common error is we think that we do all parts. So we want to do the outside, which in this case is going to be AD, times the whole thing, which is the entire measure of AC. We also want to do the outside, which is AE of one of the secants, and then the whole thing, which is AD for the second secant. So make sure you are finding the whole measurement and not just part of it. So let's go ahead and set it up by drawing our values into our diagram. So they tell me AB is 9, and that AE is 13, and ED is 12, and they want us to find the measure of BC, which again, I'll mark with an X. So let's set it up. My outside piece of the top chord is going to be 9. The whole thing, right? The number one error is you do 9 times X. So we take part times part. It's actually 9 times the whole thing. And in this case, I don't have any like terms that I can combine, so I just have to leave it as an expression, 9 plus X. Then the second chord, my lower chord, secant, is going to be the outside part, which is 13. And then the inside part, which is 13 and 12 put together, which those are expressions that we can combine. So I'm going to go ahead and add up 13 plus 12 to be 25. So then we can start to simplify. So I have my 9 outside of this group, so I'm going to distribute 9 times 9 to give me 81. And then I distribute 9 times X to give me 9X. And 13 times 25 to give me 325. I'm going to subtract 81 from both sides, which leaves me with 9X equal to 244. I divide by 9, and my X is going to be equal to 27.1 repeating. Right, so it doesn't work out to be a nice number, that's okay. Again, my X represented what they wanted me to find, so I don't have to worry about substituting anything back into the problem to complete the example. Alright, so again, the main error that we make here is that you have to make sure that you're using the whole part and not just the 9 times X and 13 times 12, right? It's not the same formula as the first example. There is a slight variation. Alright, so the third example we have is very similar, and they actually kind of confuse us by making the formula look different, but it's really the exact same thing as the last example. When we see that we have a vertex on the outside of the circle, no matter whether it's tangent secant or secant secant, if it's outside of the circle, we use the same formula. So it is still going to be outside times whole equal to outside times whole, just like the last example. Now, the reason why this example says tangent squared is because AB is a tangent line. It's touching the circle in only one point. And AB is the part that's outside, and it is the entire segment. It's the whole. So it is the outside and the whole, which is that thing being multiplied times itself, which is that thing squared. So they're overcomplicating this formula here. It's the exact same process we've been doing for the second example. So I fill in my information. AE is 5. ED is 15. And they want me to find the measure of AB, which is what I'm trying to find right here. So again, I'm going to set up my equation outside, which is AB times whole, which is AD. So I'm just going to have my X times X equal to, and then my outside, which is 5, and then the whole, which is 5 plus 15. I have to add those two pieces together. So my outside is 5, my whole is 5 plus 15, and those are numbers that I can combine to give me 20. And X times X I know that when I multiply, I add my exponent, so x squared equals 100, which is the same thing that I would have gotten if I just plugged in x squared. So then I solve my x by square rooting and square rooting. This eliminates the squared power, and I am going to get a plus or minus 10. But I know that since we're talking about a length of a segment, I can't actually have a negative 10, so the only possible answer is x equals 10. So the algebra will be slightly different depending on what information we're given about all of our figures. But again, it's pretty basic algebra. It really is just setting up your equation correctly and solving. The very last example that we have is a little bit trickier. So let's try and figure out which formula we want to use. I know that my vertex is on the outside, which means I'm going to use outside times whole equal to my outside times my whole. We can call these owl problems because it's outside times whole. Ow. So then my outside for the top segment is going to be 6, and the whole is also going to be a 6. So my 6 times 6 is equal to the outside for the bottom line is going to be x, while the whole is going to be the entire segment x and 5. So here my outside is x, my whole is going to be x plus 5. Those are not like terms, so I cannot combine them, so I have to write that as an expression, x plus 5. And now let's try and simplify as much as possible. 6 times 6 is 36. X times x, when I distribute, gives me x squared, and x times 5 gives me 5x. Now, this is a little bit of a challenge because they did give us this hint. I need to factor. How can I factor if I have a 36 on one side and an x squared and an x on the other? I need to move everything to one side. So I'm going to move my 36 so that I have set my equation equal to 0, x squared plus 5x minus 36. Now I have an expression that I can set up a factor table for. So I want to set up my t-chart. I don't need to use AC method because I have a 1 in front of my x squared term. So if I set up my t-chart, I set up negative 36 first. I'm going to find the numbers that multiply to give me negative 36, that add to give me a 5. So I know that I have 36, I have 4 and 9, and I know that I want to get a negative, so I'm either going to have a negative 4 and 9, or a 4 and a negative 9, but I want to get a positive 5, so 9 minus 4 is going to give me a positive 5. These are the factors that I want, which means my factors are x minus 4 and x plus 9, but those are not the x's. I want the solutions, not the factors, so I need to keep going and solve and set this equal to 0. X minus 4 equals 0, x plus 9 equals 0. Add to both sides, so my x is equal to a positive 4. Subtract from both sides, I have x equal to negative 9. So I have two answers here, but if I'm looking back at my diagram, are both of these answers possible? No, because again I'm talking about a segment length, and I know that a length cannot be negative. So negative 9 is not an actual answer. The only possible answer in this scenario is x equals 4. Alright, come ready tomorrow with questions. We will be practicing more problems like this tomorrow in class, so make sure you bring your packets and your notes with you.